Hello everyone, Gaza Mutkarsh, and I welcome you all to this session on data preparation for BI and analytics. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding the star schema and its associated concepts. So for its implementation, we'll be looking at let's say table creation for the star schema in SQL, and then we'll be solving questions based on the star schema. So till the previous session, we have discussed let's say how to handle null values, the malformed values, how to clean data using views, and we have discussed the different date time and the text based functions in SQL in both MySQL and Postgre. So let's get started with this session. So I'm switching to the MySQL window. So guys, first of all, we need to understand what star schema is all about. So guys, when we talk about star schema is a type of database schema used in data warehousing. All right, so it is essentially a primary concept of data warehousing, how we are maintaining the database or how we are maintaining the tables in the data warehouse. So essentially we have two schemas, we have star schema and then we have the snowflake schema. So currently we'll be discussing the star schema. So this is so in star schema there is one central fact table that contains measurable and quantitative data. All right, it contains measurable and the quantitative data, right? So it is surrounded by multiple dimensions table that contain descriptive attributes related to the facts. So over here we do have one fact table that contains the majority of the data, but all the associated tables that depend on the fact table, right? They are present in the multiple dimensions table that contain the descriptive attributes related to the fact table. So the structure resembles that of a star, hence the name, the star schema. All right. For instance, suppose I want to have the students detail, right? So majority of the students data will be present in the central table, which is the fact table. Now all the associated tables such as the course and let's say the bio. All right, so means I'm trying to show you a visual representation of what star schema looks like. So students is the fact table. Now the associated details from the students are the student bio. So this is the student bio. Then we have let's say this is associated with the students table. Then the course details are associated with the students table. Then maybe we have let's say okay, we have the faculty details for the course, and using which the student is let's say the on which the student is enrolled is also present. And likewise we can have let's say student grades. All right, student past grades. So means currently I'm only representing 4 tables for the lack of better whiteboard because I'm utilizing SQL. So over here this pattern resembles that of a star. Student is a fact table, the central table. Now we have n number of dimension tables associated with it, such as the course table, we can have the faculty details table, we can have the student bio table, we can have student past grades table, right? So these are the tables associated with this fact table. So this is just one example. Why are we calling it the star schema? Because the structure resembles that of a star and hence the name. So we have one central fact table and then multiple associated dimension tables that contain the descriptive attributes relative to the fact table. So let's understand the components of the star schema, right? So what are the components? So we have the fact table. Fact table is a central table with numeric metrics. Essentially the numeric metrics, for example, we can have sales, revenue, quantity. Then we have n number of dimension table. So dimensions table are meant for the lookup tables, right? Using which maybe we can connect them using join. So we have the lookup table with textual descriptive attributes such as product, customer, time. These are the dimension tables that we may have. It completely depends on the fact table that we are considering. So this is just an example. All right. Then we have the primary key and the foreign key relationship. So primary key is the unique identifier in the dimension table, and foreign keys. So the fact table uses the foreign key to join with the multiple dimension tables. So primary key happens to be unique and not null, whereas when we talk about foreign key, it can have let's say duplicates as well. It can have null values as well. All right, so a single table can only have one primary key, whereas when it comes to foreign key, a single table may contain multiple foreign keys. So these are the components of the star schema. So we have these 4 components. So let's create a table and understand the concept. How are we designing the star schema pattern in MySQL? So over here, the example that I'm considering is the fact table would be the fact sales table, where I'll be having the sale ID, the product ID, the customer ID, the date ID, the store ID, the quantity sold, and the total amount. This would be my, these columns would comprise my fact table. But before creating the fact table, I'll be creating the associated dimension table, and based on the dimension table, then I'll be populating the fact table, right? So what all details do we have in fact table? So we have a dimension product table where I'm having all the product details. Then we have a dimension customer table where all the customer related demographics will be maintained. Then we'll be having a dimension date table that will contain the calendar information related to maybe when was the product ordered, when has the customer, let's say, uh, joined a particular brand, maybe for the sake of ordering. What is the, let's say, maybe the birth date, and additional details would be present in the dimension date. Then we have the dimension store. So this is the store location info from which the product has been ordered or maybe purchased or sold. All right, so these are the four tables that we'll be working upon as the dimension tables, and then on top of it we do have the fact table. So let's proceed towards building the dimension tables and the table schema. So the first table that we're building is the let's say product details table, right? So let's identify the columns that we need to have in the product details. So in the product details table, this is the table. This would be the table name, and the table structure would contain, in the product detail table we'll be having the product ID, then we'll have the product name, and then we'll have the category, and we're also going to have price. So for each product, there has to be some product ID, right? Then followed by the product name. It has to belong to some category. Category could be, let's say, it could be home decor, it could be electronics, it could be men's accessories, women's accessories. Then an associated price for each product. So over here, I'm creating a table with the syntax create table dem product. We do have 4 columns. We do have product ID because each product will be uniquely identified with its product ID. So I'm setting the product ID as integer primary key. The product ID is set as integer primary key. Next, I'm having the product name. Product name is set as varchar 50. So it can contain maximum of 50 characters. Then I'm setting the category. Category is again a varchar. So I'm setting this as 30. Next, I'm setting the price. So price is meant to be in decimal. It can take up to 2 decimal places. After decimal, there can be 2 more, means after dot, we can have 2 more decimal places. So over here, I'm creating this table dimension product. All right, and I've already created this table. Let me drop the table and I'll build it from the scratch again. So it might have some dependency. All right, so it says it cannot drop because it is referenced by foreign key in some another table. No issue. So this table is already created. Let's have a look at the insertion values. So the values that I'm inserting into the dimension product table are as follows. So at ID1, I'm inserting laptop. The category is electronics and the price is 75,000. The second product that I'm adding is the smartphone. The category is electronics and the price that I'm having is 40,000. The third product that I'm adding over here is category is the desk, and the category is furniture and the price is 15,000. The next product that I'm adding is chair, and the category is again furniture and the price is 5,000, right? So these are the values and they have already been inserted. I'll show you. Select star from dimension product. All right, let's run this. So guys, as we can see, this is the data. We have product ID, product name, category, and price, and these are the details, right? These are the details that we have. So product ID, product name, category, and price, we have 4 products. So the first dimension table we have completed. The second dimension table is the dimension customer. So let's have a look at the customer demographics that we want. So for the customer table, what all fields do we need? We need to have a customer ID. So the first column would be the customer ID. The second column would be the customer name. Third column would be gender. And the fourth column would be city. I need at least these 4 columns. We can add more columns as well if need be. So for this dimension customer table, how do I go about creating this? So I'm creating it like this. Over here, I'm writing create table dimension customer. And then over here, I'm passing the customer ID. This is going to be integer and primary key. All right. So the dimension customer is the customer ID and this is integer primary key. Then I'm setting the customer name as the varchar 50. So no customer name can have characters. The name of the customer cannot contain more than 50 characters. Then I'm passing the gender with category 1, means I can only pass either male or female, right? So it can only take up to 1 character. Then the city, I'm setting it as varchar 30, means city names cannot contain more than 30 characters. So again, I've created this table already. So let's insert the values into this table. So we have 4 columns, we'll be passing the records. So over here I'm inserting the data into the dimension customers table, and what all values am I inserting? At ID1 I'm inserting Raj Sharma, the gender being male, the city being Delhi. ID2 I'm inserting Neha Singh with the gender female and the city being Mumbai. At ID3 I'm inserting Amit Patel with the gender male and the city as Ahmedabad, and at ID4 I'm inserting Priya Iyer, the gender being female and the value being Chennai and the city being Chennai. So the data is already inserted. Let me display you the values. So over here I'm writing select star from dimension customer. So if I run this, this is the data. So currently in the customer table and in the product table, there is no common column. In the customer table and in the product table, there is no common column. So this is what we have. We have product ID, product name, category, and price. And this is what we have as the customer table. We have customer ID, customer name, gender, and city. All right, this is what we have. Next, I'm passing the dimension date. Next, I'm passing the dimension date. So over here, let's just look at the values that we have. So in the table dimension date, this is the date table, right? So I'm calling it the dimension date. The table is dimension date. What all columns do we have? I'm passing the date ID, then I'm passing the full date, then I'm passing the month. So next I'm passing the year, then I'm passing the quarter. So this is going to be my dimension date table containing the columns date ID. So every date will have some ID. Then I'll be passing the full date, then the corresponding month, year, and the quarter. So let's create the table for the same. So this is the syntax for creating the table. Over here I've mentioned create table dimension table, and then the values that we have over here are date ID, which happens to be an integer. This is going to be the primary key because so that each date can be uniquely identified. Next I'm passing the full date. Full date happens to be date. Then I'm creating another table called month, and this month will take the value of varchar. All right, this month will take the value of varchar. Then the year happens to be integer, and the quarter happens to be varchar 5. So month cannot take more than 15 characters, and the quarter cannot take more than 5 characters, and year happens to be in integer. So we have 5 columns, and this table we have created. Next, I'm headed to inserting the values. So the first, let's say, insert into dim date values. So the first value ID is 101. The order date is 2025-601. The month is June, and over here I'm passing 2025. The quarter is 2. Then for the second ID 102, the date is 2025-602. The month is June, and the year is 2025, quarter 2. The third order date is 2025-603, month being June, year being 2025, and the quarter being 2. So the data has been inserted. So let's see the data. So over here I'm passing select star from the dimension date, and once I execute this, this is what I'm getting. I'm getting the date ID, then the full date, then the month, the year, and the quarter. All right, so we have 3 records. So in the dim date we have 3 records. All right, how many records do we have in these two tables? So we have 4 records each, right? We have 4 records, and again for the dimension product we have 4 records. So in all the 3 tables, means in the dimension customer and in the dimension product table, we have 4 records each. And as far as the dimension data is concerned, we have 3 records. All right, as far as for this data is concerned, we have 3 records. Then I need to pass the dimension store. This is the 4th table. Let's understand the table structure. So the dimension store table contains 3 columns. So first I'll be passing the store ID. The store ID from which the store ID in which the product was available, and the store ID from which the product has been ordered and even sold, and maybe let's say shipped as well. So then we have to pass the store name, and then we have to pass the region. So these are the 3 columns that we have in the store table. So let's go about creating this table. So how do we create this table? I'm creating this table like this: create table dimension store. All right, dimension store is the name of the table, and then what are the values? So the values that we have are we have the store ID, which happens to be integer primary key. Then we have the store name. So the store name happens to be varchar 50. Then we have the region. So region is let's say varchar 30, right? The region that we have is varchar 30. So once this is done, I've created this table. So containing store ID integer, store name varchar 50 means the store name cannot have more than 50 characters, and the region cannot have more than 30 characters. So once this table is created, I can go about inserting data into this table. So what all values am I going to insert? Currently I'm going to insert into dim store values. I'm inserting 3 records at ID1. Let's say I'm passing the store name is Delhi Central, the region is North, All right, and at ID2 the store name is Mumbai Mega, the region is West, and at ID3 I'm passing the store name as Chennai Hub and the region is South. So the data has been inserted. Let's check the value. Select star from dimension store. So guys, we have 3 records, right? Even in this table we have 3 records. So we have 2 tables with 2 records and we have 1 table with 3 records. Next we do have the fact table. So we are going to create the fact table, the table name being fact sales. So let's look at the columns that we have. This will contain a lot of columns. So fact sales will contain, first of all, it would contain the sale ID. All right, secondly it would contain the product ID, then it would contain the customer ID. All right, then it is going to contain the date ID, then the store ID, then the quantity sold, then the total amount. All right, these are the columns that we have. These are the columns that we'll be creating. So the fact sales table contains the sale ID, means each unique ID representing each order, then the product ID, in that particular order ID which product was ordered, and it was ordered by whom, as in which customer ordered that product ID, and then what is the date ID to which it belongs, on which date was the product ordered, then the store ID, what is the store from which the product was ordered, then we have the quantity, and how many quantity was the product sold, and what is the total amount, right? So these are the fields. So let's create the fact table. So over here I'm creating the fact table with sale ID, which is integer, and I'm setting this to primary key. Then we have the product ID, which is integer. Then we have the customer ID, I'm setting this to integer. Date ID is again integer, store ID I'm setting this to integer, quantity sold is integer as well, and then the total amount, right? So total amount I'm setting this up to decimal 10,2, means 2 decimal places. So let's say 2 digits it can take, it can total be of 10 digits with after decimal 2 places. So what are the foreign key? So this product ID has to be a foreign key in the fact sales tables, which should refer to the dim product and the product ID, right? So foreign key product ID, it is referring to the dim product ID. Then I'm passing the customer ID. Then I'm passing the customer ID. So it is referring to the dimension customer ID. All right. Next I'm passing foreign key date ID. So this is referring to, let's say, dim date ID. This is referring to the dim date ID. Next, I'm passing the store ID, and this is referring to dim store ID. So we had 4 tables, right, to begin with. Product ID refers to the dim product table product ID, customer ID refers to dimension customer table customer ID, then the date ID refers to the dimension date ID, and the store ID refers to the dimension store ID. So this table has been created, and these are the records that I'm inserting. So in the fact table, I'm inserting 111. So 111 indicates sale ID, product ID, customer ID, and the date ID. So sale ID, product ID, customer ID, and the date ID. And then I'm passing store ID. Store ID is 1. The quantity sold is 2. Total amount is 1,50,000. Then sale ID 2, product ID 2, customer ID 2. The then 101 is the date ID and the quantity is 2, and this is the date ID is 2, and the quantity sold is 1. The price is 40,000. And likewise we have 343 sale ID 3, then product ID 4, customer ID 3, 102 is the date ID, then 1 over here is the store ID, 4 is the quantity, the total price is 20,000. Then for the sale ID 4, the product ID 3, for the customer ID 4, for the date ID 103, 3 over here, 3 over here is the store ID, and then 1 is the quantity, and the total amount is 15,000. So we have inserted the data into the fact sales, right? So these are the records that we have in the fact sales. So let's check this. Over here I can write select star from fact sales. Now based on this fact sales, we can even combine the tables and let's say implement the details. So clearly we have created the fact tables, all the tables we have created. So let's check the details that we have. All right, so this is the table schema. I'll be writing the table schema. So we have 4 records. Fact sales contain a lot of records, in fact. Not a lot of records, but a lot of columns. So these are the columns, right, that we have in the fact sales. And we have a total of 4 records. we have 4 records. So let me write the table schema. This would be easier for us to understand. So this is fact sales, and then we have the dimension store. So the dimension store, this would be select star from dimension store. All right. These are the columns that we have in dimension store, and in dimension store we have how many records? 3 records. All right. So this is about dimension store. Then we have dimension product and dimension customer. So these are the product details, right? The table is dimension product, and these are the columns. So dimension product, these are the columns. All right, and we have 4 records. Then we have dimension customer. So dimension customer has these columns. Yeah, these are the columns for the dimension customer. These are the columns for dimension product, dimension store, and we have one more table. Select uh, star from dimension date, and in dimension date again we have 3 records only. And what are the columns in the dimension date? So we have date ID, then we have full date, then we have month, then we have year, and then we have quarter. These are the columns that we have. Let me check this dimension date. Dimension store is here, store ID, store name, region. So dimension store, store ID, store name, and region, this is done. This is for the dimension product, and this is for the dimension customer. So now this makes us easier to understand the table schema, right? And this is the schema for the fact sales. So next we have the dimensions to dimension date. The last one is the dimension date, and yes, these are the columns that we have. Store ID, dimension date. Okay, dimension date is over here. We have date ID, full ID, month, year, and quarter, and this is what I've mentioned over here. And we have 3 records. So suppose I want to find what is the total sale amount by the product category. So product category is present in the product table, right? Dimension product table. So we have to combine the dimension product table and the fact sales. So currently we are moving on to solving questions based on the star schema. So over here I'm writing select p dot category, which is present on product in the product table, and then summation of f dot total amount as the total sales from the fact table SF, and then join dimension product table P on f dot product ID is equal to p dot product ID, and I'm grouping it by the product category. So guys, just have a look. For electronics the total sales is 1,90,000. For furniture it is 35,000. Likewise I can solve what is the total unit sold within each month. So for each month, so month is present in the date table, right? In the dimension date table. So over here I've mentioned d dot month, and then sum of f dot quantity sold as the total units sold from the fact sales F, and then join by dimension date D on what is the joining condition? F dot date ID matches the D dot date ID, and I'm grouping it by D dot month. So if I were to run this, so I'm getting for month the total units sold were 8, because there was only 1 month data. Next I can check which region generated the highest sales. So over here I'm passing region by sum of total amount as the revenue from the fact sales F on the dimension store S on f dot store ID is equal to s dot store ID, and I'm grouping it by s dot region. So I'm ordering it by revenue in the descending order, and I'm limiting it by 1. By limiting it by 1, because I only need the region that is generating the highest sales, right? So once I execute this, so see, north region is generating the highest sales. Now if I were to, let's say, get rid of this one limit, so it would return all the regions with the sales. So north is 1,70,000, west is 40,000, south is 15,000. So if I want the highest, so I need to limit the number of records to 1. So for this we can use the limit clause. All right, so this is where we are using the limit clause, and this is how it works. Next I'm checking for customer wise revenue. So how can I extract the customer wise total amount generated? So over here I'm writing, C dot customer name, then sum of total amount, sum of f dot total amount as revenue from the fact sales F joined by dimension customer. So fact sales F is joined by dimension customer C on f dot customer ID is equal to C dot customer ID, and I'm grouping it by C dot customer name ordered by revenue descending. So this is customer wise revenue. So we had 4 orders. So each customer has contributed. This is the revenue generated by each customer in their descending order. Let's solve one last question. So I want quarterly sales summary by category. So again, this is based on the star schema concept. So D dot quarter, I want quarter by sales. So there was only one quarter to begin with, quarter and category wise, quarterly sales summary by category. So for each quarter, I want to display the category wise sum of total amount as the total sales from the fact sales F on, and I have to join it by product category. So dimension product P on F dot product ID is equal to P dot product ID. I also need to join it with the quarter. So I have to use dimension date D. I'm aliasing it as D on F dot date ID that matches with D dot date ID, right? So this is what we have. This is where I've joined everything. I've joined the three tables: fact sales, dimension product, and the dimension sales, dimension date. So I'm grouping it by D dot quarter and P dot category, and then I'm ordering it by D dot quarter and the total sales in the descending order. So let's run this. So guys, for quarter two electronics, the total sales is 1,90,000. For furniture, it is 35,000. So guys, that brings us to the end of this session. So in this session, we have understood the star schema and its associated concepts. We have implemented, let's say, a problem statement based on the star schema where we have considered multiple dimension tables and one fact table, right? And we have joined the two tables and based on which we have solved multiple problems. So in the next session, we'll be moving on to denormalization concept and its implementation. Thank you.